just it is within our country or within our location. So just for that, we are now working on towards enhancing the cyber law so that we can um, go cross border too, right? So even the click, a single click that we are doing in the internet is transmitting some data. I think you will be knowing about the problem that Facebook has faced. So Facebook had released nearly 50 million user profile has been cracked, and they were paying nearly $5 million as penalty, which is a 20 times greater the penalty that that people have given so far. So this is just by um, a quiz that the Facebook user, they have attended a quiz hosted uh, by one person, I don't remember his name. So he had posted a quiz in the Facebook, and that quiz has been attended by so many people, and from that they got the data, and the psychological analysis has been done, and it was used to advertise the political campaign. So that is a problem. So even we are collecting big data, so we have to be very careful when we are clicking a link. And even that you will be getting so many phishing mails saying that your bank data banking account will be closed if you are not entering these datas, and we'll be clicking the link, and we may give the data, and we may lose our information. So we should be very clever when we are clicking any links, right? So that is just an introduction. Now we are moving to the technical part of the web security. So technical part of the web security, we can provide web security at network layer, transport layer, and application layer. So network layer, we can use IPsec protocol. Transport layer, we will be using SSL and TLS protocol. And application layer, we can use Kerberos, SMAME, PGP, set protocol, etc. So today I'm just going to concentrate on SSL, and then set, and if time permits we'll look into the IPsec protocol, right? So SSL stands for secure socket layer, and also we call it as TLS, the transport layer security. So both are same. SSL has been designed, and later they have adapted SSL version 3 as TLS protocol. So just for naming convention, we are using SSL. Actually we are implementing TLS, right? So organization has to install SSL certificate on the web server. So first I will focus on the server, and then we will be moving towards the SSL protocol. So as an organization, we have to install the SSL certificate on the web server that we are using, so that the people, those who are accessing the web server, will can access it securely. So the browser also has to enable it. So the browser has to be enabled with the TLS security feature, and the server also has to provide the SSL certificate. So all certificate is just the certificate, in the sense it will be providing the public key with the signature. So providing a private public key pair. So someone wants to verify us, means they can verify it with the signature that is provided in the certificate. So we'll have a look into it in the further slide. So first, we know that HTTP. So whenever in olden days we were using only HTTP, and nowadays all the sites are HTTP. Yes, during 2016 itself, nearly 50% of the website has changed to HTTPS. So if you are using HTTP, it will be like this HTTP, and the domain name will be there. If it is to be secured, then you will be using HTTPS. So here S stands for security. So if it is secure, then you will be getting a green symbol like this in your padlock, right? So now whenever you are having you have your web server and your browser, you are going to communicate through the internet, means it should be secure. So in order to be secure, we are going to use HTTPS, which is the SSL certificate added to the HTTP, that is the HTML implementation. So this HTML document that you are sending through the HTTP is through the secure manner that is known by HTTPS. So if you don't have HTTPS, you can you it is better not to use it. Nowadays they have enabled that HSTS, so that is always confirm that the browser is going to browse HTTPS. Even though you are visiting a site which is not HTTPS, the uh, the system will take care that it is visiting only HTTPS, and if it is just a HTTP, it will not allow it inside, and the web server will provide you only the HTTPS protocol, right? So this is a introduction about HTTP. Yes. So what is your SSL certificate? It is small data file which is installed in the web server, right? And your browser should be capable of accepting those certificates, right? So it activates the padlock and the HTTPS protocol. So your HTTP, your padlock, or the tab where you see your website, it will be HTTPS. So it is just a digitally binding the cryptographic key to the organization detail. So the organization means the organization website. So website will be in the web server and it will be providing you the SSL certificate. So through the certificate, you can verify that the browser is capable of using HTTPS, as well as the web server is providing you the perfect site, or you can authenticate the organization using this certificate. So how you are going to use it? When you are going for a credit card transaction, or your personal information transfer transaction, or you are going for a bank login, or you are going to access any social media sites. Nowadays they are using it for even social media sites. So any of these transactions which is to be done securely, we have to use this SSL certificate, right? So as I told you, HTTP, yes, it will be using, so it will be preventing the intruder from tampering into the communication. So what the intruder can do? The intruder can actively monitor you, as well as passively he can monitor you. So actively monitoring means he can grasp the sensitive information. He can install a malware into the system, and also he can post a advertisement into the website, into the legal website that you are viewing. So these are the active activity the intruder can do. And passively he can listen to the communication and understand your behavior. So this will be even this is also a data. Your behavior itself is a data. He can understand where you are going, what you are doing, so those information can be understood. So we have to be very careful in adding this security. So what are all the type of SSL certificate it is available? If you are going for a small business site which don't need much security, then you can go for a it will be verified, or you need not give any hard copy verification. The verification will be done only through your mail. So they will be sending you a mail, sending a link to your mail. The clicking of the mail is enough to verify it. So for simple basic sites, you can go for a domain validation. It will be quickly issued. The certificate will be quickly issued. Then extended validation is that this is the very important one, and the highest security feature which is it is providing. So when you are using extended validation, you can see the address bar will be changing green. Even though if you are using HTTPS, it won't change green. When you are going for a extended validation certificate, the address bar will change green. So this will say that you are more secure. You are using a more secure site, and here it will be verifying not only the organization. It will be even verified by the browser. So the browser also will be verifying the organization, as well as the organization certificate also will be verified. So that is the extended validation. Then unified communication, you can use it for your email, and you can link multiple domain to it. Then the next type is subject alternative name. So this can be used for multiple domain. They may not be a relevant one. And wildcard, it will be having a main domain and all the subdomains. So main domain and all subdomains can be verified just by using this wildcard certificate. Then organization validation, it is similar to the extended validation, but it will not show the green here. So these are the types of certificates that is available. you are if you are creating your website, you can go for at least for the basic type, which will provide the security. So how to enable the security? So you can go to your control panel, and you can just search for the internet option, and under the internet properties, you will be having the advanced tab. In advanced tab, you will be having the security. So under that, you can see you are going to use which or you are going to adapt which version of the TLS or SSL. So you have to tick this so that your browser will be SSL certificate enabled. So each and every browser have their own CA authorities whom they are authorizing. So those things we can browse, and we can look into it. So after, if your browser is SSL enabled, then the web page also should be SSL enabled. So that you will be getting your HTTPS. So how can you check whether it is a TPS and who is the certificate authority? Is that just you go and click this lock. So when you click this lock, it will be displaying some information like this. There's a connection and whether it is using a microphone or not. Then the notification, what are the cookie it is using, and what setting it is allowed for this particular website. So those information you can see along with the certificate. So when you click this source certificate, you can see tab opens like this, and here you will be having the general detail and some path. You can click each and everything, and you can see what is the public key, what is the that you are using, RSA, SHA. So what algorithm they are using, those details you can see. And the certificate part, so this is very important. You'll be having certificate will be provided by the certificate authority. So you can see that this is for the Google site. So Google Trusted Service is the global signed root certificate is being used. Then the sub certificate issuer is the GST CA 101, and then comes the last the final certificate for google.com. So you can click these things, and you can view the certificate, you can download it, and you can even surf the net, and you can check whether the certificate is valid or not. So it will be this is a big concept: certificate authority issuing the certificate, revoking the certificate. So those information you can search in the net, and you can find it out. So actually the browser will be checking it. So the browser will be connecting with the server known as the online certificate status protocol server. So this server will help to check this certificate, right? So the browser will send it to the OCASP server and check whether the certificate is valid or not. So if the browser need not send, it can even get the certificate status from the web server. So the web server will provide the certificate status. With that, it can complete the verification and it can proceed. So you can check the certificate by clicking into this lock. Right. So now we are entering into the technical concept. So I think you may be knowing what is the symmetry key encryption. You are using the encryption and decryption. You are using the same key, then it is symmetry key. And if you are using different key, that is the private and the public key, then we call it as a asymmetric key encryption. Right. So private key encryption or public key encryption. So in the public key encryption, you can use both a private key for encryption or public key for encryption. So accordingly, it will be changing whether it is going for a authentication or whether it is going for a signature. So suppose let us consider at the source end, the data is being um, encrypted using the private key. So if it is encrypted with the private key, then public key, it is known to everyone. So anyone can view this information or anyone can decrypt it. So in this case, it will be acting as a signing and the verification process. But when you are using your public key for your encryption process, then you can use only the private key to verify it. So you can encrypt it with anyone's public key, and only that particular person will be able to view it. So you are sending the information confidentially. So if you are using your asymmetric key, you can provide confidentiality as well as the digital signature process too. right? So certificate authority, you will be having a root certificate authority who will self sign the certificate, and then he will be having the intermediate certificate authority, and at last the user will be receiving the certificate from the intermediate certificate authority. So if you want to verify the user certificate, they will be having the signature there. So that signature will be verified by the public key of the intermediate certificate authority. Then the intermediate certificate authority certificate can be verified by the root certificate authority's public key. So like this it will be going, it is a chain of processing, right? So whenever we talk about the certificate, whether it is SSL or PGP, whatever it may be, whether even if it is a IPsec where you want your private public key pair, or your set protocol where you want your private public key pair, you are going for the certificate which is the X.509. So there are version 1, 2, and 3, and these are the contents that is available in X.509. So you'll be having the version, which particular version it is supporting, then the certificate serial number. So this is a particular certificate, and what is the serial number of it. So with the serial number you can find out whether it is being valid certificate, or this certificate is invalid, it has been revoked due to some problem or not. So those things can be viewed with the certificate serial number. Then comes the signature algorithm identifier. So this will specify which particular algorithm is being used for the signature. So this is the signature. At last you have the signature. Then you have the period of validity. So how long this certificate is valid? So from to date will be there. Then comes the subject name. So this is the user who's for whom the certificate is being issued. Then comes the public key information. So this is the actual public key of this particular user or this particular subject. Then the issuer's unique ID will be there. So who had issued this, or the intermediate certificate authority who had issued this certificate, that number will be here. Then the subject's unique ID. So this particular subject's ID will be there. That is this user ID. Then comes the extended version, and at last you have the signature. So this signature part is the whole thing which is being signed. That is the MAC value will be generated, and it will be signed by the private key of the certificate authority. So whenever you are getting this certificate, you can get the public key information from here, and you can check whether it is valid or not. And suppose if you want to check whether this is a authenticated certificate, then you have to verify the signature by using the public key of the certificate authority. So that's all about the certificate. So I think you must have gone through earlier. Anyway, just an introduction about it. Then, so these are the companies who are providing the SSL certificate. So if you are going for your website, you can purchase a certificate, and this Let's Encrypt is a free certificate, free SSL certificate provider, and OpenSSL is also there. So that is also a free certificate. So these are the three organization which is providing the certificate, SSL certificate nowadays, and they are the topmost in the market, and others are there. There are so many organization who are providing the certificate. So if you want, you can get it. Now, the overall figure of this SSL certificate is this. So you will be having the certificate authority who will be issuing the root certificate. Then the root certificate will be taken by the intermediate certificate authority, and they will be issuing the SSL certificate. You will be having your SSL certificate in your web server, and you will be having the private key. So this public key will be distributed using the certificate, that is X.509 will be distributing the public key to the user or to the browser which is accessing this web server. So this is how it happens. Now let us look into the technical part. So this is about just I have given an introduction about the certificate, how you are getting the certificate. So altogether, let us forget everything. Just let us remember that the public key and the private key is the pair that we are getting in the certificate. Now we are going to see how the SSL will be working, or the working principle behind it. So SSL or TLS both are same. They have a slight difference in the way they are generating the random number, generating the secret value, the shared secret. Other than that, they are same, right? So SSL, you can look into, if you want in-depth idea about it, you can look into the RFC 6101 for this SSL SSL documentation, and it has been developed by Netscape Communication during the year 1994, and they didn't release it because it had some security issue. Later they developed SSL version 2 during 1995, and then SSL version 3 during 2000. during 1996, and SSL version 3 was released with so many reviews from the industry. And later, TLS came into existence, which was compatible with the SSL version 3. So if you want to look into TLS, into RFC 2246, so before TLS, we should have some idea about SSL. Right. So it is used for the secure communication between the client and the server, or the browser and the web server. So what it is going to do, it will be preventing, so it will be providing encryption, authentication, message integrity, privacy, and reliability, and it will be preventing the mass drafting, tampering, and message for forgery. So altogether, it will be providing the security. Right. So if you look into a HTTP protocol, it will be working under port 80. If you are using HTTPS, you can see that it is working under 443. You can just go to the browser and take the source page, and you can look which protocol is using which particular port, and you can see in between this HTTPS and the transport layer, we have the SSL. SSL layer. So it is a two-layer protocol. So where it resides, so if you take your HTTP, it will be working with the TCP directly. If you take your HTTPS, it will be working in between the HTTP and the TCP protocol. So it sits on top of TCP, and you know that it is application layer protocol. TCP is a end to provide end-to-end service, but TCP and SSL together will be providing a reliable end-to-end service. So you are going to use TCP and SSL to get the security. So it is using X.509 certificate, and it uses RSA public key crypto system, and DES or triple DES, some symmetric system also it is using. So this public key crypto system or the certificate is used to securely exchange the symmetric key, and then the data will be transmitted only using the symmetric key. Right. So this is our overall architecture. You have the two layers here, the HTTP SSL alert protocol, change cipher specification protocol, and the handshake protocol. So these are the upper layer. Then comes the second layer, SSL record protocol. So all the information that we are sending from the application layer, that is the all HTTP data will be processed in the SSL record protocol, and it will be transmitted. And if you take this SSL handshake, chain cipher, and alert protocol, some SSL record protocol header will be added, and it will be transmitted. So this is the overall architecture, and let us see how it will be activated. So you'll be having your HTTP here, and that will be forming the applic part, and it will be passed to the record layer and then to the transport layer. Then before passing this data, that is this application data will be encrypted, and also it will be signed, it will be compressed. So compression, MAC value calculation, and encryption, all activity will be done on this application layer. So in order to do this, first you have to you have to exchange the certificate. So exchanging the certificate is done by using this handshake protocol, alert protocol, and change cipher protocol. So this handshake protocol will be initiating the communication to transmit the certificate from the web browser to the client, and the client to the web server to the web browser, and web browser to the web server. So this handshake will exchange the certificate and make us get the public key as well as the symmetric key. Then we have the alert protocol. So this is just for passing some information. So error handling, it will be passing the information saying that the certificate is has been will not be used again, or the session has been closed, or you want the certificate as found invalid. So those information will be passed through this alert protocol, and then comes the chain cipher protocol. So this chain cipher protocol will help you to agree on the information or the data that you have transmitted using the handshake protocol. So we'll look into these things in depth. So all these information added with the record layer header will be transmitted to TCP. So altogether, HTTP will be directly transmitted to TCP if you are using HTTP itself. If you are using HTTPS, the secure socket layer will act in between the HTTP and the TCP protocol. Right. So now, how this what is the size of these things? You can see that have your handshake protocol. So handshake protocol, you'll be having 1 byte which will be specifying the type, sorry, and 3 byte which will be specifying the length, and then comes the content. And HTTP application layer protocol, the data you will be sending as such, it will be doing some processing and you will be sending as such. Then the chain cipher specific is a single byte protocol, and alert protocol is a 2 byte protocol. Protocol, it will be specified by a hexadecimal number. If you are saying that it is a alert protocol, it will be specified by a number. Even the alert information will be given some number. So those things we can refer to the documentation, RFC documentation. So the first layer here is this handshake protocol, chain cipher, and alert along with the HTTP, which will be passed to the second layer protocol, where the SSL record protocol will be added and then passed to the TCP. So now, so before entering into this alert, saying say for a handshake protocol, which is going to transmit the certificate, let us just have a look into how this HTTP will be processed. So if you are taking this HTTP in the sense the information that you are going to transmit. So the application data which you are going to transmit will be fragmented. So it will be divided into fragments of particular size, and then it will be compressed. So this compression process is optional. If you want, you can compress it. Otherwise, you can directly pass it. So after compression, or even before, even if the compression is not, the fragment will be taken and you will be applying a hash value. So hash function to it. So this hash function is just with the shared secret key. So you are having a key which is being shared. So that handshake protocol will help you to transmit the, as I told you, the handshake will help you to transmit the certificate. So it will be helping to transmit the certificate, that is the public key as well as the symmetry key. So those symmetry key, we call it as the pre-master key. That master key, pre-master, will help you to generate the master keys and the session keys. So from that key only this will be generated. So the generation itself is a big process. I have not included it over here. Just understand that handshake protocol will help you to transmit public key and the symmetry key, that is the pre-master key. From the pre-master key, the key that is needed for encryption as well as the hash value calculation will be generated. Okay, so now the compressed data is passed through the hash function, and you are applying a key to it and you are generating the MAC value. So this MAC value along with the compressed data will be undergoing a encryption process. So here too the same way the key will be generated and it will be used, and this key is then added with the SSL. Sorry, this encrypted data will be added with the record header and it will be passed to the TCP layer. So this is how the application data is handled. Application data is taken, fragmented, compressed, MAC value is added, encrypted, record is added, and then it is being transmitted. So this is the data transmission. Now, so how the compression process? Just we have seen a compression process over here. After compression, it is going to the MAC processing. So the MAC processing is here. The compressed data will be taken. So this is the XSL compressed fragment. Along with this, you will be adding some header. That is the SSL compressed length. Then what type of compression you are using. Then what is the sequence number of this particular fragment. Then padding. So you will be filling it with some value. So those padding value will be added. Then you will be having the MAC write secret. So MAC write secret is the secret that we are using for this MAC calculation. So the secret that is being shared. So everything will be added here. It will be concatenated and then it will be passed to the hash algorithm. So it may be a MD or a SHA algorithm where it will be generating the extract, that is the hash value. So then it will go for the second level of hash calculation. So this is added, this H1, which is the output of the first hash algorithm, will be added with the padding value 2, and then once again the max secret will be used and then it will be generating a hash value. So this is how this hash value or this particular h of generation is done using this processing, and then this will be added to the compressed data, right? So this is how your data is being sent. So next is the information, how the just what is the max secret though. So the explanation is given here. So pad 1 is just a constant hexadecimal number 36, which will be repeated as many times according to the algorithm that you are using. So if you are using MD5, it will be repeated 48 times, and if it is a SHA algorithm, it will be repeated 40 times. Padding 2 will be a 5C hexadecimal number, which will be repeated once again 48 for MD5 and 40 times for SHA. Then others all the sequence and the compression type, length, and the fragment. So this is the overall algorithm that this picture is implementing, right? So now, so we have the completed the fragmentation and compression, encryptions, etc. So now you'll be having the plain text, compressed text along with the mac which is being encrypted. So this data will be added with the record protocol header. So this is the header part which will be added. So what is the content type? The major version, minor version, and the compressed length. So content type will specify whether it is a data or that is the HTTP data or your cipher specific protocol, handshake protocol, or alert protocol. So what protocol that you are passing here, or what information that is passing here, it will be specified by the content type, right? So now you'll be having the session and the connection state. So connection state in the sense already the session has been established. So under a particular session you can generate so many connections. So so many connections can be under a single state. So you can enable a new connection under a session, or you can enable a new session. So if you are enabling a new session or a new connection, you have to send the handshake protocol, and according to the information in the handshake protocol, it will understand whether to enable a connection or enable a session, right? So let us have a look into the other three protocols. So we had a look into the HTTP and how it is being processed and sent to the SSL record protocol. Now we are going to look into the remaining protocol, the first layer protocol, the handshake, chain cipher, and alert, right? So now, first one we are going to concentrate is the chain cipher specification protocol. It is used in the handshaking protocol. So it is a single bit of information which will have a value one. It will be a information to the client as well as the server, saying that we have agreed on the algorithm and the key that is to be used, and now let us start using the agreed on values. So that is the information. So chain cipher specification will change the pending state to the copied state, and from then onwards they will be starting the usage of the new agreed protocols and algorithms. Then the alert protocol. So as I told you, the alert protocol is a 2-byte protocol. So one byte will be specifying the level and the other byte will be specifying the alert. So first one is the level. So there are two levels, the warning and the fatal message. So warning means it is just a information, so it will not be considered very seriously. So when it is a fatal information, it will be understanding that the information is very critical and it has to terminate the connection. So that particular connection will be terminated, but the other connections in that session will be continuing, but new connection will not be established. So it will be stopping the terminating that particular connection. All other existing connection in that particular session will be continuing, but new connection will not be established. So these are the alert. So these are the alert information. You can give the information like no certificate, bad certificate, decompression failure, the certificate expired, it has been revoked. So these information can be passed using the alert protocol, right? So now we are moving to the very important part. So as I told you, we have gone through the SSL protocol, HTTP, how it is processed, and what is the chain cipher, then alert protocol. Now we are moving to the very important part, the handshake protocol. So the handshake protocol is the one which is helping to transmit or exchange the information between the client and the server. So it is having a four phase. So it will be establishing a security capability, then the server authentication, the key exchange, third phase client authentication and key exchange, fourth phase is the cipher specific and the finish message. So this is the overall structure. You can see that you have the client and the server. So phase one, server may optional, this is optional, server may send a hello request, and if the client want to respond to it, it will be responding, otherwise it will ignore client hello request. Then the client will send the hello, then the server will send the hello. It means that they have completed the hello and they can start exchanging the certificate. So phase two, server will send the certificate, and if the certificate is not there, then it will be sending the key. So certificate and the key exchange will be happening here, and it can even request the client to send its certificate, and it says it has done. Then the client will be exchanging the certificate if it has, otherwise it will be saying the alert message that I don't have the certificate, like that. Then it can exchange the key. So it will be exchange the key. So after exchanging the key, it can say that you can verify the certificate. So after completing phase 3, the authentication process will be over, and they would have agreed on a particular key that can be used for the transmission of data. After that, it moves to the chain cipher specification protocol. This chain cipher specification and the finished message will be sent from client to server, as well as server to the client, saying that they can proceed with the agreed on values. So this is the overall picture. Now just I have given a screenshot of the Wireshark implementation. So I think you know about the Wireshark. Wireshark is a tool which will be capturing the packet that is passing through our network. So this is a sample part where they are using or the handshake protocol happens. So you can see the protocol is the TLS protocol, and you have the client hello, server hello, then the server key exchange. So here itself you have the server key exchange, then the client key exchange, then the chain cipher and the encryption handshake message. That is the finish message. So these are the uh, four phases of the handshake protocol, and then comes the application data. So let us just explore it, have a look into it, how it looks like. So now, as I told you, the hello request, it is a first information sent by the server. If no, if so client want to respond, it can respond. Otherwise, it can just ignore it. Then comes the client hello. So this client hello is just a single information which will be containing the client version. So it will say the client will support these particular versions of SSL. Then it will be sending a random number. So this is a 28 byte random number which will be used to generate the session ID later. Then it will also have a session ID. So session ID may be a non-zero value or the zero value. Non-zero value means it is exchanging the information which is related to this particular ID. If it is zero value, it means that it is opting for a new connection. So session ID, then comes the cipher suit. So the client will say these are the particular cipher suit that I can. Okay, so these are the particular cipher suit that I can accept. Cipher suit in the sense which particular MAC algorithm, which particular encryption algorithm, what is the compression method. So those things are the cipher suit. So those information will be represented by a number. So those things are given in the documentation. So those information, those numbers will be sent. So now after receiving this client hello, so this is how the client hello looks like. You can see that this is the client hello message. So if you have if you implement your install your Wireshark, you can just click it and you can see the information. So as I told you, when you are clicking this particular client hello, you can see the expanded message which will look like this. So it is a TLS protocol, it is a client hello message, and the content type. So this is the content type, version and length, which is a part of the record protocol. Then comes the handshake protocol. You can see it is a record layer. Then comes the handshake protocol. So the client hello information. So what is the type? The type of the information is the client hello, then the length and the version. So this is the type, length and the version, which is a header of this handshake protocol. Then comes the random number. So as I told you, you will be having the session ID length, then the cipher shoot, what it is supporting. So the length of it is 56 and it is listing. It has been not listed here, but it is providing a 28 different algorithm that it can support. Then comes the compression length and what is the compression method that they are using. So it has accepted only one method that is not listed here. So here 28 different encryption algorithm that it is supporting, and here one compression method it is supporting. So this is the information which will be sent by the client to the server through the client hello message. Then comes the server hello. So the server hello also will be having the server version, random number, session ID, cipher suit, and compression method, same like the server client hello. But the difference is that client will say that I can support these things, and server will say that I have accepted on these things. So I will be providing you support in this particular algorithm, in this particular compression method. So like that information will be sent from the server to the client. So this is the first phase. So here you can see that you have the server hello, So the server hello method, the random number session ID, and the server had accepted with this particular cipher suit. That is, it is not going to do any compression. Compression is zero, and it has accepted to use the RSA algorithm with the AES 128-bit cyber block chaining mode, and it is going to use SHA for for the MAC value calculation. So this is referred by this particular number. So 27. So it has sent 28 different value. Cipher suit, and out of that this particular cipher suit had been accepted by the server. So now the acceptance, that is the algorithm acceptance, is over. Now it has to exchange the key. So algorithm acceptance is over. After that, what particular key that you are going to use for that particular algorithm, that we have to decide. So that is on phase 2 and 3. So server certificate, so server will be sending a certificate, and then it can even send its key. Then it will be asking the client to send its certificate. Then it will be sending it has done, and you can verify my certificate, and then start exchanging the certificate and key from your side. So this is the information in the phase 2. So how it looks, it is just a part of this server key exchange data. So it is a server key exchange mechanism, and it is using a Diffie-Hellman parameters. So these are the parameters that it has been accepted for Diffie-Hellman key exchange. So this will be used to calculate the Diffie-Hellman. So I think you know about the Diffie-Hellman algorithm, how it will calculate the key. So it will be having some numbers, and at both the side they can generate their own value, exchange it and combine it, and they will be generating the key. So that is how the Diffie-Hellman algorithm works. So those information, that is parameter that is needed for the Diffie-Hellman key exchange, will be transmitted here. So it is having a elliptic curve. That's why they have used the curve and all. Then what hash algorithm they are using, then the signature length, then the signature is here. So this will be helping you to verify it. Then comes the client authentication and key exchange. So here too, if the client has a certificate, he can send the certificate, otherwise he can send the key, and then he can send the certificate verify. So if he is sending the certificate, he can send the verification information for the certificate. So this is how the client key exchange will look like. So it has accepted with the Diffie-Hellman parameter, and it will be sending the public key length and the public key. So this will be used by the server to generate the original key. Right. So at last comes the phase 4, the change cipher specification and the finish. So this message will be sent from the client to the server, as well as the server to the client. So what is this change cipher specific? I told you it is a acceptance of the key as well as the algorithm, and the finish message is the encryption of all the information that they have transmitted so far. So this is the information. It will be sent from both the server to the client as well as the client to the server. So first it will be sending the change cipher specification, and then it will be sending the finish. So finish value is just a encrypted handshake message. So the complete handshake message will be taken, and it will be encrypted using the key that has been exchanged now, and it will be sent to the other side. They will be verifying it, and they accept on, and they can establish the session. So this is how the SSL protocol works. So at last, after completing on the processing or after establishing the session, they can start transmitting the data. So the record transmission will be happening by the session key that they have transmitted. So the session key would have been exchanged by this time, or they will be using the Diffie-Hellman to generate the key, and that key will be used for transmitting the application data. All encryption, compression, everything will be done with that particular key. So the overall structure of the SSL protocol is that it is going to compress the it is going to take the application data, it is going to do some compression, MAC value, encryption. So for all these things, it will be supported by these protocol. So whatever information that it is sending, it will be sending through the SSL record header adding to it. So that's all about the SSL protocol. So if you have any doubt in this, you ask. Otherwise, we'll move to the next protocol. Any doubt in this? It is very altogether. The structure is that the certificate will be exchanged between the server and the client. So certificate will be having the public key. Using the public key, they will be generating the symmetric key, and that symmetric key will be used to encrypt the data, application data. Okay.
Yes, ma'am, it's okay.
Okay, so let me proceed with the set protocol. So the second protocol that we are going to see is the set protocol. So set protocol is for the e-commerce transaction. It is very simple, and you can see that it resides in the application layer. So the SSL and the TLS protocol, it resides above the TCP and below the application layer. So set protocol is a application layer protocol. So it resides in the above the application. So whatever application that you are sending, it will be secured using the set protocol. So even there are other protocols. So this SMAME is the secure protocol for mail transmission. So those things are I didn't cover those things because I think it will maybe covered in some other sessions. Okay, so now we'll concentrate on set. So the important feature of the set protocol is that it is providing the security transparently. That is, it will be above the application layer, and it will be providing the security at the application layer. In addition, it will be supporting SSL, TLS, IPsec, whatever other layer security it is providing, it will be supported. So that is the beauty of this set protocol, and mainly it is used for e-commerce transactions. So set stands for secure electronic transaction. So this was developed by the Mastercard and the Visa card. So credit card transaction. So in order to secure the credit card transaction or the debit card transaction, they are using this set protocol, and mostly for the credit card transaction where you will be having the user and the customer and the merchant. So you have to do the authentication between the customer, merchant, as well as the credit card provider. So all these things has to be authenticated. So multiple entity is there, and multiple entity authentication is needed. So in that case, we are going for this secure electronic transaction. So it is a industry backed standard. It was formed by the Mastercard and the Visa card during the year 1996, and it had got advice from many companies. Right. So this is the only protocol that will be providing security as well as authentication. So security through authentication is provided by the set protocol. So this is a peculiar protocol which will be very much helpful in secure fund transfer. So it will be it ensure message confidentiality as well as security. So authentication, security, and confidentiality is provided by this set protocol. So it relies on the cryptography and X.50 version 3 digital certificate. So here too you can see that we are using the certificate. So X.509 is the certificate that is used by the SSL protocol as well as the set protocol. So wherever you need a public key, you can go for this X.509 digital certificate, right? So it protects the transaction information that is being on transit. So it will be on transit, it will be securing the data, right? So it will be keeping the information securely encrypted all the times by using the digital certificate to verify the identity. So it will be encrypting the data all the time, and it will be selectively encrypting the data. It will be selectively hiding the data. That is, order information will be hidden to the bank, and the banking information will be hidden to the merchant. So this is how the information is being separated, or we call it as a dual signature through which the process is happening. Let us have a look into it. So who are all the business requirement? So it is not so clear, sorry for that. So business requirement of set is confidentiality of the information. So the information, the customer who purchased the goods and the merchant who is issuing the goods should be confident that the information is being securely transmitted. Then the integrity of the data on transit, it should not be modified, so that we should have a faith that the information is proper. Then the cardholder account should be authenticated. So if I am accepting the card, it means that the account is a valid account. So the cardholder account has to be authenticated. Then the merchant should be authenticated. So merchant authentication is also very important, so that the customer can go for a confident purchase. Then comes the security techniques. So the security techniques is the dual signature. It is a very important point in this, for providing the security. Then the creation, it is a brand new protocol which will be a transparent protocol which will accept all other lower protocol. Then interoperability, whether you are using a Visa card or a Mastercard, whether it is being payment gateway is a HDFC bank or the Paytm bank, whatever it may be, it should be interoperable. So that is, it should be acceptable. So that is the business requirement for set. So now the set system participants. So who are all the participants? The cardholder, issuer, merchant, accruer, payment gateway, and the certificate authority. So just to have a look into what you have, the cardholder here. So the cardholder will be looking browsing into the merchant site, and he will be interested in some good, and he is going to place the order. So when he is going to place the order, uh, he should place the order information along with the credit card information. So now you can see the merchant is there. Merchant will be getting the order information, and he will be passing it to the payment gateway. That is the information, bank transaction information or the credit card information will be passed to the payment gateway. Gateway will be verifying whether this card is a valid card, whether it is having the credit limit and all. So those information will be verified by the payment gateway, and the payment gateway will be informing the accruer that all the verification has been done, and you can collect the amount. So the issuer will be giving the amount to the accruer, and the merchant will be delivering the product to the cardholder. So this is the overall structure. So now how step by step how it is happening. So the customer will be browsing and decided to purchase. So when he decided to the purchase, he will be sending the order and the payment information. So here comes the set protocol. So the order and the payment information should be secured to the particular level which is needed. So merchant means it should have some particular level of security. To the bank means it should have some particular level of security. So that is provided by this set protocol. So the order and the payment information will be sent to the merchant, and the merchant will forward it to the bank. That is, the merchant bank is the accruer. In between, you can have the payment gateway. So the payment gateway will help to accept any card from any bank. Then the merchant bank will be verifying it with the issuer bank, that is a customer bank check with the issuer for the payment authorization. So the credit limit, everything will be checked, and the issuer will be authenticating it. So once it is getting the information from the issuer, the bank will accept it, and it will be saying the merchant that it is okay, you can go, you can play, you can just get complete the order. So now the merchant will complete the order, and then it will be capturing the transaction. Merchant bank will collect the amount from the customer bank. So this is how the said transaction happens, and the protocol plays here from the second step onwards. So each and every level from the second, third, fourth, fifth step onwards, it will be very much helpful. So how it is going to ensure the confidentiality, integrity, and authenticity. How it is going to ensure it is based on the dual signature. So dual signature is a way to verify the information. That is, it will be giving the level of information. Suppose, okay, let us look into the diagram and come. So here is the customer. You can see that the customer resides here. He is having both information, the order information as well as the payment information. So now the customer will send the order information to the merchant in plain text, and the payment information to the bank in plain text. Plain text means not plain text, secured with the key, known only to the bank. It means that it is known only to the bank, and here too it is known only to the merchant. So the order information will be sent to the merchant with the secured with the key, known only to the customer and the merchant. Then the order information is hashed. So it is undergoing a MAC algorithm, and the hash value is generated. Now the payment information is also there. Here too the hash value is generated. So you can see the hash value of the order information and the payment information is taken. It is concatenated, and once again it is hashed. So this hash value will be encrypted. So how you are encrypting? You are encrypting with the customer's private key. So KSC is the customer's private key. So customer, if he is encrypting with his private key, it means that it is like a signature. Now the bank as well as the merchant can use the certificate where you will be having the public key of the customer. So the public key of the customer can be used to decrypt this information. So you can see the order payment information, the hash value concatenated. Once again, it is hashed. So it is the dual signature. So double time it is signed and it is being passed to the bank as well as the merchant. So now the bank and the merchant will be looking into the customer certificate, and he'll be using the public key of the customer to decrypt it. So when they decrypt it, they will be getting this hash value. So this hash value is the order information and the payment information, hashed hash value of the order and the payment information. So now it is available at this particular point, and you can see the payment information is not sent to merchant and the order information is not sent to bank. But how they are going to get this hash value? So you can see this, the payment information hash value is passed to the merchant, and the order information hash value is passed to the bank. So order information, plain text, it is sent to the merchant, and the payment information hash value is sent to the merchant. So now the merchant will generate the hash value of this order information at his point, and he will be taking this payment information hash value sent by the customer. He will be concatenating it and he will be generating a hash value, and then he will compare it with the hash value that it has been decrypted. So this decrypted hash value and the generated hash value, if they are same, then it means that the customer order information and the payment information are authenticated. Similarly, at the bank side, bank is not bothered about the order information. So it is concerned only with the payment information. So it will be receiving the order information as a hash value and the payment information as a plain text. So now this payment information and the hash value of the order information will be concatenated and the hash value will be generated. So this will be once again compared with the decrypted value. Now the bank can confirm that this order information is valid. Now the bank and the merchant can exchange the uh, amount. So this is how the security is being applied. So it will be using a dual signature to verify it. So that's all about the set protocol. So how it is, how the processing will be done? The card holder has to first register and get the card. So this verification will be handled through some offline mode or some secure channel. And similarly, the merchant has to register, and he also has to get his payment gateway. So now the card holder and the merchant has registered, and after registering they will be getting their certificate. So registration will help them to get the certificate. So after getting the certificate, the customer will be purchasing, the purchase request will be placed, and then the payment authorization will be done by the merchant. After authorizing, the payment will be captured and the amount will be transmitted. So this is just a overall picture about the set protocol. So everywhere here to all the key that they are using is the public key private key pair, which is by this X.509 certificate. So those certificate will be used for authentication. So that's all about this set protocol. So if you have any doubt in the set protocol, you can ask. I didn't go elaborate into the set protocol because even a cardholder registration is a tedious process. If I start that, I cannot complete it. That's why I didn't enter in depth into the set protocol. Okay, I'm moving to the IPsec protocol. So what is this IPsec protocol? I have some 15 minutes, I think so. So IPsec protocol. So IPsec protocol is a protocol which resides above the IP protocol or at the layer of the IP protocol. So network layer protocol. It is also very simple. If you go in depth, it is also a very big protocol. So IPsec protocol, it is designed to protect the communication. So whatever the transport level data or the application layer data, it is not bothered about anything. All the packet that it is receiving from the TCP layer, it will be undergoing the IPsec processing. So it is a protocol which will not bother about the application that that it is using. So designed to protect the communication at the IP layer. It is an extension of our IP protocol. So it was developed during 1998, and it is in the RFC 2411. And implementation of IPsec protocol is mandatory in IPv6, and it is optional in IPv4. So IPsec, how it works? You have your internet. You are going to send the data. If it is a IPsec disabled, in the sense, you will be having your IP header, and the upper layer data will be there. That is the TCP header. Then the application data will be there. If you are going for a IPsec enabling, then you will be having your IP header, IPsec header, then the upper layer data. So in between the IP header and the upper layer, you will be adding the IPsec header. So it differs according to the modes of operation. We'll have a look into it, a brief overview into it. So you can implement this IPsec protocol between end-to-end system, or you can have it at a router. So router and a user can have the IPsec implementation. So between gateway to gateway, or between a gateway to a particular node, you can implement. So what level of implementation you are going to take, it is left to you, right? So the main important point is that IPsec protocol has two main transformation. That is two different form of IPsec, the authentication header and the ESP header. So authentication header, we call it as a AH protocol, and encapsulating security payload, which is the ESP protocol. So authentication header, as the name implies, it will just authenticate. So it will authenticate that this information is from this particular entity or the node, and it will not give any confidentiality, or the information will not send confidentially. So this encapsulating security payload will help you to provide both authentication and encapsulation. That is, it will provide authentication as well as confidentiality. So this AH and ESP protocol, they can operate in two modes, the transport mode and the tunnel mode. So just this is the overall picture. You will be have the main architecture. It is having the ESP protocol, which will be using the encryption algorithm and the authentication algorithm. You have the ACE protocol, which use only the authentication algorithm. It doesn't use the encryption algorithm. Then you have the DOI, digital object identifier, which will be specifying which particular algorithm it is going to use, which encryption algorithm, which authentication algorithm. So those identifier, that is, each algorithm is specified by an identifier, that is a number, hexadecimal number. So those reference you can find it over here. Then you have the key management. So the key management itself is a ISA KMP Diffie-Hellman. Simply to say, it will be using a Diffie-Hellman algorithm. To the higher level, to say, it will be using the Oakley model, ISA KMP model, which itself is a big protocol. So we are not going to concentrate on that. We are just going to look into the ESP protocol, AH protocol in its tunnel mode and the transport mode. So IPsec modes of operation, uh, transport mode is there, tunnel mode is there. So if you look into the transport mode, you can see that you have your uh, so this is the original packet. It is having the IP header, TCP header, and the data. So this is the original IP packet. So now when you use your IPsec, you will be inserting the IPsec header. So you can insert this IPsec header in between the TCP and the IP header. So in between TCP header and IPsec header, you are going to insert your IPsec header. So that is in the transport mode. So if you are looking into the tunnel mode, it will be giving a tunnel. That is, within that particular data transmission line itself, it will be providing the security. It will be hiding the information. Here what it does, it takes the whole IP packet, IP TCP data packet, original packet as such, and it will be adding the IP header and a new IPsec header along with the new IP header. So the whole packet will be taken and it will be added with this IPsec header and the new IP header. So you can see that the original IP header is being hidden over here. So this will help in avoiding the spoofing when we are transmitting the data. So this is the overall picture of the transmission and the transport mode and the tunnel mode. So transport mode, you will be having the original IP header. In tunnel mode, you will be adding a new IP header. So this is the AH format. So authentication header format. So this is having a next header. So which will be specifying what is the header following this particular format. Then comes the payload length. So what is the length of the payload that you are using here? Then the reserved bit is here. Then comes the important point, the security meta index and the security payload. sequence number. So what is the security parameter index? So when you're going to use your IPsec, you will be having both the end has to agree on some algorithms and the keys that it is going to use. So which particular algorithm it is going to use for encryption, which particular algorithm it is going to use for authentication. So those information will be identified by the security parameter index. So you will be having a security association as well as a security policy database. So two databases will be there: security association database and security policy database. So those database will be having the information about the security parameter index number and what are the algorithm which will be supported in under this particular SPI. So with this number, it will be identifying for this particular packet, I have to use this particular algorithm. So this will be giving, this is just a identification number. So that is the security parameter index. Then comes the sequence number. So sequence number is the number assigned to this packet. So if there is any packet drop, then you have to identify it. So those things can be identified by using this sequence number. Then comes the authentication data. So the MAC value which has been generated by the authentication algorithm will be added over here. So this is the overall AH format. Then this is the ESP packet format. Okay, we'll complete AH and come. So this is your AH. So AH, we are going to use AH in both transport mode and the tunnel mode. So you can see the AH header is added. Actually, in general, we saw that the IPsec header will be added. So here we are adding the AH header here. So IP header, AH header, and then the payload in the transport mode. In tunnel mode, the new IP header, AH header, then the original IP header and the payload will be added. So authentication, what it is going to authenticate. So the information, the complete information will be taken except the mutable field. So if you are looking into what the time or the number of hops it is moving, the time to leave, so those information will be changing. So those are the mutable field. So other than that, all other fields will be taken and it will be authenticated. So those authenticated information will be added here in the authentication header. So if you're looking into the authentication header, you have the authentication data over here. So this authentication header will be specifying the algorithm by the security parameter index and the sequence number by this field, and the authentication data will be added here, and which will be incorporated here in this particular part. Here the AH header is those information. So this is the transport and tunnel mode of the AH protocol. Then comes the ESP protocol. 1 minute. Okay, ESP protocol. So the ESP protocol, here too we have the same thing. Only thing is the data itself will be added here in this packet. So that is the difference between authentication. So authentication is just a MAC value of the data. ESP is the encapsulation which is going to encrypt. So the whole information will be taken. That is the whole IP packet will be taken and it will be encrypted. Right. So this is the security parameter index. As I told you, it will be helping to identify the algorithm that is being used for authentication and encryption. Then comes the sequence number, then comes the payload. So this is the information that you are going to encrypt and authenticate. So you have the payload data here. So the payload data will be added. So it should be in a multiple of 32. So in order to make it as a multiple of 32, you will be adding the padding values here. So zeros and at last a one will be added. So that is the padding value. Then comes the pad length. So how much of data you have added. So that will be representing the pad length. Then comes the next header. So after this data, it will be followed by the authentication data. So this is your ESP format. So now just have a look into the ESP format. You have your new IP header or the old IP header, whatever it may be. According to the transport and tunnel mode, it varies. So now, for example, I have taken the tunnel mode here. So the new IP header will be added in the tunnel mode. If it is a transport mode, then the old IP header will be there. So the new IP header is here. Then comes the ESP header. So what is your ESP header? ESP header is the security parameter and the sequence number. So this will form the ESP header. So ESP header will be added. Then comes the data. So the payload. So the payload is the complete packet. So the original IP header and the original IP header datagram, that is the data over there in the IP header will the original IP header packet will be taken, and it becomes the payload. So this is the payload part. Then comes the trailer. So what is the trailer? The padding, the pad length, and the next header will form the trailer part. Then comes the ESP authentication. So this authentication, if you want, you can use it, otherwise you can leave it. So you have your authentication over here. Now, what will be authenticated, what will be encrypted? So encryption, this ESP header will not be encrypted, because the security parameter index is needed to identify what algorithm it is used. So this part will not be encrypted, and all other remaining part will be encrypted. Here you can see the authentication data also will not be encrypted, because if you are including it here, then you have to decrypt it, and then you have to check the authenticity. So it will be time consuming. Suppose the data is being corrupted, then the authentication will fail. So you need not go for any decryption process. So before the decryption, you have to authenticate the packet. That's why it is added here. So encryption will take only the ESP trailer. That is, the trailer part is the padding part. So the payload and the padding part will be taken, and it will be encrypted. And what will be authenticated? The ESP header together will be taken, and it will be authenticated. So once the authentication is successful, you can go for decryption, and you can take the information that is stored here. So this is your ESP packet, which will be helping you to authenticate, as well as it will be providing the confidentiality of the information that is being transmitted. Now comes the ESP, the transport mode, and the tunnel mode. So the transport mode and the tunnel mode, as I told you, the transport mode, you are going to have the original IP header, and you are going to add the ESP header. In tunnel mode, you are going to add the new IP header and the ESP header, and the original packet along with its header will be taken, and it will be encrypted. So this is how the transport mode happens. You can see ESP header, TCP UDP data, and ESP trailer is here. So everything will be authenticated, and except the tunnel mode, the new IP header and the ESP header is there. So the remaining, the whole packet along with the original IP header, it will be encrypted, and then the ESP header along with that, it will be authenticated, and it will be stored in the authentication field. So this is how your ESB will be working. So the overall picture of the IP, overall picture of IPsec is that it is going to use or AH header, ESP header in its transport mode, or the tunnel mode. Avladhan. So if you have any doubt in this, you ask. So I have covered the web security at each level. So one protocol at each layer I have covered. If you have any doubt, you ask. Otherwise, I have completed my presentation.
Ma'am, there's a question from the participant in the chat box.
Yeah.
How to make web server to use SSL for its conversation with clients?
Sir, I'm
Ma'am,
not
can you
able to
just
hear you.
how to make web server to
Huh,
use SSL
huh.
for its conversation with clients?
Web server. Sir, actually, we have to purchase this SSL certificate, and we have to include it in the web server. But I'm not aware of the configuration in the web server part, because I don't have any website and web servers. So I just explored in the client point of view. Sorry, I'm not able to answer this question. But I know one thing, that we have to purchase the SSL certificate. So the configuration is given, it is there in the we can there are many sites, those providers, the SSL certificate providers, they have given, and I have gone through that, but I have not explored it, because I don't have any website and web server to implement it. I have just read it, so I cannot answer you, but it is available in the net. You can have a look into it, how to configure the SSL certificate into the web server. It is there, but I didn't explore, so I cannot answer this correctly.
Okay, ma'am. Thank you. Uh, Participants, is there any other questions? I think there are no more questions from the participant side. Uh, so
Okay.
we shall conclude.
So, yeah. So thank you all for patiently listening to my presentation. for this how it will be, but anyway, I have taken it as clear as possible and as short as I can do it. Anyway, thank you, and also I wish you all a very happy new year. And I thank the organization for inviting me for this lecture. Thank you.
So on behalf of Teaching College of Engineering and the coordinator, and also on behalf of participants, I sincerely thank Dr. Saraswati ma'am for taking a wonderful session. Thank you, ma'am. Thanks a lot for accepting our invitations and spending your valuable time here. Thank you, ma'am. Thank you so much.
Thank you, sir. Thank you all.